Probably the most undeniable evidence for evolution comes from the fossil record. So, this is an image of the famous Burgess Shale in the Canadian Rockies of British Columbia. We're going to return to the time period revealed in this incredibly rich site called the Cambrian explosion in our next unit. For now, I need you to recognize that the fossil record reveals life forms unlike anything that we find today. So, like Opabinia, this organism from the Burgess Shale, part of the Cambrian explosion, had 5 eyes and a flexible proboscis. How about Hallucigenia with its massive spines? So again and again, species emerge and die out at different points throughout the fossil record. It's clearly evident that they are not all created at once. The second big idea that I want you to recognize here is that the fossil record is just brimming with what we call transitional forms, evolutionary trajectories that span millions of years. Consider the horse. Following the extinction of the dinosaurs, about 55 million years ago, the lineage that is to become the modern horse consists of a species no bigger than a dog with multiple toes. So here we go. This is the lineage that is to become horses. 55 million years ago, very small, you can see multiple toes. As we move through time, this lineage becomes larger and larger, its legs longer and longer, and its toes progressively fuse into the single hoof in the genus Equus, the horses and the zebras. All of these adaptations, presumably to avoid larger and faster mammalian predators. We also see lots of beautiful transitional forms when we look to our own lineage. 7 to 9 million years ago, our ancestors had a cranial capacity and a brain size comparable to a modern day chimpanzee, like you see here on the upper left hand side. By 2.5 million years ago, the Australopithecines B and C had evolved. Like Lucy in the Sky with Diamonds, these were hominids. They were now bipedal, upright, which you're going to read about here soon. And their brains were becoming larger. When we get to the genus Homo, starting here with Homo habilis almost 2 million years ago, and then down here to Homo ergaster, right? We've got hominids that are fashioning more complicated stone tools that are likely wielding fire. The Neanderthals here and here, whom we interbred with in Europe like 50,000 years ago. So if you're of European descent, about 2% of your DNA is Neanderthal. It comes from this admixing. The Neanderthals, 700,000 years ago, were burying their dead. They were creating art. They likely had rudimentary religion. So we'll come back to the Cro-Magnon, right? And the cave paintings from Lascaux in France. We'll come back to that in a later unit. Until we arrive at anatomically modern Homo sapiens some 200,000 years ago. My point is, when we objectively look at this fossil record, we see a beautiful transition of forms. We see evolutionary trajectories. So let's return to that blue whale on the first slide to check out the progression of whales from land to the sea.
Whales are the biggest animals of all time. heavier than elephants, woolly mammoths, and even dinosaurs. But they weren't always the titans of the sea. Let's rewind the clock around 50 million years. No, you won't find any whales here. You have to go ashore. Meet Pakicetus, the very first whale. Life on Earth spent millions of years clawing its way out of the oceans. But whales took all that effort and threw it out the window. From 50 to 40 million years ago, they traded in their forelegs for flippers. In fact, some whales today still have leftover bones of hind legs. Once submerged, their weight under gravity no longer mattered, so they could theoretically grow to enormous proportions. And they did. Today, a blue whale is 10,000 times more massive than the Pakicetus was. But this transformation wasn't as gradual as you might think. In fact, over the next 37 million years or so, whales grew increasingly diverse, but their size remained small. For example, one of the first whales with baleen instead of teeth was only 18 feet long, making them easy prey for predators like giant sharks. It wasn't until around 3 million years ago that an ice age tipped the scales in the whale's favour. Ocean temperatures and currents shifted, sparking concentrated swarms of plankton and plankton-seeking krill. It was an all-you-can-eat buffet for the baleen whales, who grew larger as a result. And the larger they became, the farther they could travel in search of more food to grow even more. You can probably see where this is going. 3 million years later, humpbacks, for example, have one of the longest migrations of any mammal on Earth, travelling over 5,000 miles each year. As a result, modern whales are the largest they've ever been in history. Take the biggest of the bunch, the blue whale. It weighs more than a Boeing 757, has a belly button the size of a plate, and its network of blood vessels, if you laid them out in a line, could stretch from Pluto to the Sun and back, over 2.5 times. In fact, the largest blue whales are so huge that scientists think they may have hit a physical limit. When they open their wide mouths to feed, they engulf enough water to fill a large living room, so it can take as long as 10 seconds to close them again. Scientists estimate once a whale is 110 feet long, it can't close its mouth fast enough before prey escapes. So it's possible we're living amongst the largest animal that will ever exist. Lucky for us, they mostly just eat krill. This was made in large part thanks to Nick Pineson and the information in his new book, Spying on Whales.